So in this question, we're asked to calculate the integral of sine 3x times cos of x, and we're going to do this using the integration by parts technique. So we know for integration by parts, what we're looking for is kind of two individual functions in our equation, and these are multiplied together. So we can see that's what we've got here. We've got a sine of 3x multiplied by a cos of x. So this here I've written as the integration by parts formula. So we're going to try and use this in order to calculate the integral. So let me start off the question by actually writing out this integral. So sine 3x cos of x being integrated with respect to x, and we're going to set all of this up in the equation. So you can see we've got a u and a v dash. So we can define that in our equation here. So I'm going to make u the sine of 3x and the v dash the cos of x. I think for this question it doesn't really matter which way around you do it, it will work both ways. So that means that if u is equal to sine of 3x, I can find its derivative, and it's going to be 3 from the 3 in here, sine goes to cos, and the bracket remains the same, so that's just applying the chain rule. We know that v dash over here is equal to cos of x, so what we want to figure out is v, so we need to integrate, and the integral is going to be sine. Remember, you can double check. Sine, if you take the derivative, it goes to cos. Alright, so now let's write out this part of the equation, so uv minus u dash v dx, and let's substitute in with this stuff that we've kind of pre-worked out. So u is equal to sine of 3x, v is equal to sine x, and then we need to take away, it's going to be 3 cos of 3x multiplied by v, which is, I'll just get rid of this sine of x, and then dx. Alright, so what we can see has happened here is that we've ended up with an integral that still would need the integration by parts technique to figure it out, because we have a function with x multiplied by another function with x. So what we're going to see though is if we do actually evaluate what this integral is, it should end up reverting back to something that looks like what we started with. So here you can see the cos is attached to the 3x. Back here we had the sine attached to the 3x. Alright, and here the sine is attached to the x on its own. Here the cos is attached to the x on its own. So if we integrate this, I would expect it to go back to something that looks like what we had before. So let's do that as a bit of a side step. I'll pop it down here. So we want the integral of what we kind of end up with. And again, I'm going to have a u and a v component, a u and a v dash component of my equation. So I'm going to go with this bit being u and this bit being v dash. And just to distinguish from what we had before, I'll put a little subscript 1 on this time for them. So that means that, u1 is equal to 3 cos of 3x. And if we take the derivative of this function, I'd expect it go to, well, I'll do it in steps. So it's going to be the 3 out the front. Cos here goes to negative sine, and we copy out the bracket, and then multiply by the derivative of what's inside because it's the chain rule. So this is going to simplify to negative 9 sine of 3x. And then if we work on the second one, we know that it's equal to sine of x. So if we take the integral of this function, it's going to end up being negative cos of x, alright, because the derivative of cos is negative sine, so we get a double negative, making it a positive down here. Alright, so now we need to apply our integration by parts rule, and I'll just copy out the equation again, and I'll put the little subscripts on this time just to differentiate them. Alright, so let's substitute into this equation. So it's going to be 3 cos 3x multiplied by v1, which is negative cos of x, minus, and then u1 dash is negative 9 sine of 3x, and v1 here is negative cos of x dx. Alright, so let's clean this up a little bit. So we've got 3 cos of 3x, and it's going to be a negative, alright, from the negative here, equals And then we've got a triple negative going in here, so overall that's going to be negative. And it's going to simplify to 9 3x cos x dx. Alrighty, so all of this here can be substituted in for the integral, alright, which was up here. So if I call this one, let's go with equation 1, and we'll call this equation 2, what I should be able to do is substitute this back up here. Alright, so I'm going to copy this across. So it's the integral of sine of 3x cos of x dx, and it's equal to, so this first part stays the same, so sine of 3x sine of x, and then we're minusing away, this is our equation 2, so minus, and I'll bracket it off, oh that was a bit of a messy bracket, all of this. Okay, so now what we need to do is a bit of simplification. So you can see that what's happened is we've ended up with this sine 3x cos of x, which is what is expected. It's the same kind of form as what we started with. So what we were going to aim to do is put this and this together. So in order to achieve that, I'm going to expand out this brackets. So double negative here becomes a positive. And again, we've got a double negative, so it's going to become a positive. All right, now, we know that a constant, we can bring it out the front of the integration sign if we want to. So I might do that. And so now we've got 9 of these integrals. So what I can do is bring this to the other side of the equation and combine it with this one. So this is one of those integrals. So when I bring this to the other side, it's going to become negative. So it's going to be 1 minus 9 of those. So overall, that's negative 8 of those integrals. And all I'm left with is this stuff here. Cool. Alright, so my final step is I just want to answer with this integral on its own. So I can bring my negative 8 across to the other side of the equation. And that's going to leave me with this. Alright, all divided by that negative 8. And the only other thing I need to think about is this is an indefinite integral. So I need to answer my question with that little plus c on the end. So this here is one way of expressing that integral that we were looking for. So that's pretty much all there is for this question.